Hi everyone, welcome to this tutorial on Verilog HDL. I am Goura and today we are going to break down procedural blocks in Verilog step by step. So grab a pen and let's dive right in. Procedural blocks. In Verilog, procedural blocks are used to describe behavior that changes over time. These blocks contain combinational or sequential logic that executed either once or repeatedly based on triggers like clock edges or changes in signal states. Procedural blocks can be two types. One is initial block, another one is always block. Now we will discuss in details about initial block and always block. For initial block, the initial block is used to execute code once at the start of the simulation. Typically used for test benches, initial setups, and signal initialization. It does not repeat or respond to changes in signal once it is done. The syntax for initial block is initial, then being, then statement, then int. The keyword being an int is used for multiple line statement. If there is a single line statement, we can avoid the keyword being an int. In this example, at time 0, we initialize the identifier reset to 1. After 5 time unit, we assign reset to 0. For always block, the always block is used to describe logic that runs repeatedly, either continuously or triggered by signal changes. This is where the core of combinational and sequential logic is written. There are different ways to trigger an always block. Always block can be triggered by sensitivity list, or it is triggered by combinational logic, which is also called implicit sensitivity list, or it can be triggered by sequential or clock logic. Always block with sensitivity list. The block executes whenever a signal in sensitivity list changes. This sensitivity list specifies when the block should be triggered, such as pauses for positive edge or neg for negative edge. The syntax of always block with sensitivity list. Always, then at the rate of, then sensitivity list inside the parenthesis, then being, then statement, then int. And of course, the keyword being an int is for multiple line statement. If it is single line statement, we can avoid the keyword being an int. In this example, we put A or B as the sensitivity list. This statement will execute whenever A or B changes. If A or B changes for 2 times, the statement will execute for 2 times. If A or B changes for 3 times, the statement will execute for 3 times. This is like this. Always block with combinational logic, or always block with implicit sensitivity list. The keyword at the rate of A star inside the parenthesis automatically triggers the block when any signal used inside it changes. This is ideal for combinational logics. The syntax of always block with combinational logic is always, then at the rate of A star inside the parenthesis, then being, then statement, then int. And of course, the keyword being an int is for multiple line statement. If there is a single line statement, we can avoid the keyword being an int. In this example, we put A star as sensitivity list, so the statement automatically triggers when A or B changes. Always block with sequential or clock logic. Age triggered blocks describe sequential logic, typically with flip-flop or registers. The block executes when the specific edge of the clock signal occurs, typically pauses for positive edge or neg for negative edge. The syntax of always block with sequential or clock logic is always, then at the rate of, pauses clock or neg reset inside the parenthesis, then being, then statement, then int. And of course, the keyword being an int is for multiple line statement. If there is a single line statement, we can avoid the keyword being an int. In this example, on every positive edge of block, the count will increment. If the reset signal is low, then the counter is reset to 0. Blocking and non-blocking assignment in procedural blocks. Inside a always or initial block, blocking and non-blocking assignment are used. Blocking assignment executes sequentially. It is used for combinational logic. Non-blocking assignment allows for parallel execution, used for sequential logic, especially in clock blocks. Difference between initial and always blocks. Initial block executes once at simulation start. On the other hand, always block executes repeatedly based on sensitivity list. Initial block is commonly used in test benches and initial setup, but always block is commonly used on combinational and sequential logic. Initial block has no sensitivity lists, but always block has custom or compiler defined sensitivity list. Initial block has time control delay. On the other hand, always block typically avoided time control delay. Common use of procedural blocks. Procedural blocks used in test benches. Initial blocks are used in test benches to initialize inputs, apply stimuli, and check outputs. In this example, we write a part of test bench which contains initial block. We monitor time A, B, and sum from A, B, and sum, and at time 0, we initialize A to 0 and B to 0. After 5 time unit, we assign A to 1 and B to 1. And after 10 time unit, we finish our simulation. Always block in combinational logic. Combinational logic can be implemented using always at the rate of star inside the parenthesis. Blocks with blocking assignments. In this example, we write a Verilog code for AND gate using always block. Always block in sequential logic. Sequential logic is typically implemented using always blocks triggered by clock edges with non-blocking assignments. In this example, we write a Verilog code for D flip-flop behavior using always block. Summary of this tutorial is: initial blocks are executed once, generally used for initialization and test benches. Always blocks are triggered by signal changes or clock edges and are used to describe combinational and sequential logic. Proper use of blocking and non-blocking assignment is essential to avoid race condition and ensure correct logic.